Hello everybody, this is Mr. McNair, and these are the questions from the 2007 OGT that have to deal specifically with measurement. If you could, go ahead and pause the video and read through these tips. Before we get into the questions, I want to go over this problem. In 1 week, you work 8 hours and 30 minutes. If you make $10 per hour, how much did you make that week? Well, you know that you're making $10 per hour, right? $10 per hour. So we know that we're going to multiply 10 times however many hours we work. That's $10 per hour. Well, how many hours did we work? Well, we worked 8 hours and 30 minutes. So we're going to plug in 8 hours and 30 minutes for 8. So 10 times, well, how do I plug in 8 hours and 30 minutes? What number is that really as a decimal? Well, that's really 8.5 because we know that 30 minutes is half of an hour, right? So let's say you didn't know that. You should know at least that there are 60 minutes in 1 hour. So because there are 60 minutes in 1 hour, you could go to your calculator and say, okay, well, we want 30 divided by 60. Okay, 30 minutes in an hour. 30 minutes divided by 60. So that's 0.5. So from there, you would be able to say, okay, well, 8 hours and 30 minutes is the same thing as 8.5. And then you would multiply 10 times 8.5, and you would get that you would make $85 that week. Okay, that's the same thing. Let's do some more. That's the same thing as if, let's say you wanted to do 15 minutes. Well, 15 minutes out of an hour is 0.25. Okay, so that would be 0.25 of an hour if you're doing 15 minutes. And same thing with 45 minutes. 45 divided by 60, that's 0.75 of an hour, so on and so forth. Okay, all right, so let's go ahead and go into an actual problem. Number 4, Helga earns $6.30 per hour working part-time at the grocery store. She records her starting and ending times each day on her time card. Okay, and then Helga gives her time card. In your answer document, determine Helga's total wages for the week. Show your work or provide an explanation for your answer. All right, so once again, we know that Helga, let's get a different color going here. Helga makes $6.30 per hour. Okay, so we know that we're going to take $6.30 and we're going to multiply that times however many hours she works. That's what we need to find out here first. So that being said, let's go through each day and figure out how many hours she worked each day. So on Monday she worked from 10:30 a.m. to 2 p.m. So to be honest with you, when I do problems like this that have to deal with time, I use my fingers and just count. So I know from 10:30, 11:30, that's 1. So I put up my 1. From 11:30 to 12:30, 2, 3 to 1:30. So, and then from 1:30 to 2, well, that's not a full hour. So we have 3 full hours. And then from 1:30 to 2, that's another 30 minutes. Well, remember, we don't want to just write 3 hours and 30 minutes. We want the decimal version of that. So that would be 3.5 hours, right? Just like we did before in the calculator, we're going to take that 30 minutes and we're going to divide it by 60. And we know that 30 minutes is half of an hour. So that's 3 hours, and that's 3.5 hours. All right, let's do the same thing on Tuesday. On Tuesday, we're going from 12:45 p.m. to 3:30 p.m. So from 12:45 to 1:45 is 1. From 1:45 to 2:45 is 2. From 2:45 to 3:45 would be 3, but that's over our time. So if we went up to 3:45, that would be 3 hours, but that's 15 minutes over. So that's really like 2 hours and how many minutes? 45 minutes, right? All right, you could have said, okay, well, up to 2:45 is 2 hours, and then from 2:45 to 3:30, that's 45 minutes also. All right, so this is going to be 2 point how many? 2 point what? So 45 again, 45 divided by 60. That's 0.75. So that's 2.75 hours. All right, we didn't work on Wednesday. On Thursday, we went from noon, 12 p.m. to 4:45 p.m. So again, let's count. So to 1 p.m. is 1, 2 p.m., 3 p.m., 4 p.m., and then 45 minutes. So 4 hours and 45 minutes. Hopefully you know already that 45 minutes, just like here, was equated with 0.75. So this is 4.75 hours. And then on Friday we went from 11:15 to 3:45. So to 12:15 is 1, 1:15 is 2, 2:15 is 3, 3:15 is 4. And then from 3:15 to 3:45, how many minutes passed? So we did 4 hours so far. And then from 3:15 to 3:45, that's another 30 minutes. And just like up at the beginning, 30 minutes is half of an hour. So this is 4.5 hours. All right. So now let's go ahead and add up our time. You really want to add up the decimal times, okay? Because those are the ones that are going to give you the most accurate answer. So if you add up 3.5 plus 2.75 plus 5.75 plus 4.5, we get a total of 15.5 hours. Okay? So she worked 15.5 hours, and she makes $6.30 per hour. Okay? So let's go ahead and type that in our calculator. $6.30. So let's clear this out. $6.30 times 15.5 hours. Oops, I missed my 1. 15.5 hours, and we get a total of $97.65. So 6.3. So 6.3 times 15.5 equals $97 and how much was it? $97.65. $97.65. So that would be your answer. All right. Good. Let's move on. Next. Enrica took 2 days to drive 1,020 miles. On the first day, she drove 10 hours at an average rate of 62 miles per hour. On the second day, her average speed was 57 miles per hour. Approximately how long did she drive on the second day? All right, so this problem, you know that it took Enrica 2 days to drive 1,020 miles. 2 days and 1,020 miles. On the first day, she drove 10 hours at an average speed of 62 miles per hour. So she went 62 miles every hour, 62 miles per hour for 10 hours. So how far did she go on that first day? 62 miles per hour in 10 hours. All right, so you would do 62 times 10. So she drove a total of 620 miles the first day. We'll just say on day 1. 620 miles on day 1. Now, we know that she drove a total of 1,020 miles. Okay? So that means there's how many miles for her to drive left? Well, if she drove 620 miles on the first day, and there's a total of 1,020 miles, so let's find out how many miles are left. 1,020 miles minus the 620 miles she drove on the first day. So we have 400 miles left. Okay, so there's 400 miles left. So she drove 400 miles on day 2, and she drove it at a speed of 57 miles per hour. All right. So we know that to find out how many hours, that you could do distance equals rate over time. Distance equals rate times time. Excuse me. So here we could take the distance, which is 400 miles, the rate, which is 57 miles per hour, and multiply it by the time, which we don't know. So let's divide by 57. So 400 divided by 57 is, let's see, 400 divided by 57 is 7.01. So we get that the time is approximately 7 hours, 7.0 hours. So her approximate time is 7 hours. Okay, great. Let's move on. Before we go into the next question, let's talk about this theorem. It's called the Pythagorean Theorem. Pythagorean Theorem says that a squared plus b squared equals c squared when a and b are the legs of a right triangle. And c is what's called the hypotenuse. Okay? Now, the legs of a right triangle are the sides that are attached to the right angle. And you know it's a right angle because you'll have this box here. All right, so the legs are those sides attached to the right angle. Okay? The hypotenuse is the side across from the right angle. It's the longest side, and it's across from the right angle. So in a problem like this, I could find out what x is by plugging in the things I know into the Pythagorean theorem. So a squared plus b squared equals c squared. Well, a squared, a is going to be one of the legs, doesn't matter which one. So 6 squared plus b squared, that'll be the other leg, 8 squared equals c squared. Okay, what is 6 squared? Well, that's 36. Plus what's 8 squared? Well, that's 64. And that equals c squared. Well, 36 plus 64 is a total of 100. So c squared is 100. Well, we don't want to know what c squared is. We want to know what c is. So to get rid of the squared, we have to do the opposite, which is square rooting, or the inverse, I should say. So a squared and a square root cancel out. So we get c, and the square root of 100 is 10. If you don't know how to do the square root in your calculator, all you do is you hit second, and then there's a square root right above the x squared, and type in your number. So the square root of 100 is 10. Okay, be careful because square rooting is not the same thing as dividing by 2. Okay, you're asking yourself here, what number when I multiply it by itself gives me 100? Well, 10 times 10 is 100, so that's the square root. So here we find out that x is 10. Okay, another way you could use the Pythagorean theorem is if they give you one of the legs and the hypotenuse. Let's use a different color here. They give you one of the legs and the hypotenuse. You can plug it in to find the other leg. Okay, so let's do that. A squared plus b squared equals c squared. So let's say a squared is 12 squared plus b squared, we don't know. We don't know what that is. That's going to be x squared. B squared equals c squared, which is 20 squared. Let's simplify. 12 squared is 144 plus b squared, we still don't know. 20 squared equals 400. All right, let's solve for b. Okay, so to solve for b, we would subtract 144 from both sides. So these cancel out. You'll get b squared equals, that's going to be 256. And then, just like before, we don't want to know what b squared is. We want to know what b is. So how do you get rid of a squared? Well, the opposite of, or the inverse of squaring is square rooting. So we're going to square root both sides. Whatever you do to one side, you have to do to the other. So the squared and the square root cancel out, leaving you with b equals, when you type in the square root of 256, you get 16. So b is 16. So that's what that is, 16. Whoops, 16. There we go. All right, let's look at an actual problem. Marcia's house is approximately 10 miles east of the airport. A jet is flying directly over her house after taking off from the airport and flying approximately 12 miles as shown in the diagram below. So they give us this figure here, and we see that this is a right triangle. Okay, so that should be a hint. You can only use the Pythagorean theorem when it is a right triangle. So we have that. Approximately how many miles high is the jet when it flies over Marcia's house? So we want to know, what is this distance here? What is that? Well, once again, because we know we have a right triangle because of this right angle, we could use our Pythagorean theorem. Pythagorean theorem, a squared plus b squared equals c squared, when a and b are the legs of the triangle and c is the hypotenuse. Okay, so here we know a squared or b squared could be 10, so we'll do a is 10 squared plus b squared. We don't know. We'll just call it b squared still. Equals c squared. C squared is always going to be the hypotenuse squared. Okay, so that'll be 12 squared. Well, what's 10 squared? Let's simplify. That's 100, plus we still don't know what b is, so that's b squared. What's 12 squared? That's 144. Now let's solve for b. So let's subtract 100 from both sides. So we get, I'll write it over here a little bit, save myself some space. B squared equals 144 minus 100, that's 44. Okay, and once again, we don't want to know what b squared is, we want to know what b is. So we have to get rid of that squared. Once again, the opposite or the inverse of squaring is square rooting. So we want to square root both sides. The squared and the square root cancel out. So that leaves you with b equals, well, let's see, what is the square root of 44? Let's type that in our calculator. So the square root, we hit second, and the square root is above the x squared. Square root of 44 equals 6.63. So we get b equals approximately 6.6. And what do you know? That's b, 6.6. All right, there we go. Let's keep going. Before we go on, let's talk about some parts of a circle. This right here, we have a circle, and this is called the radius. The radius goes through, it starts at the center and goes to a point on the edge of the circle. Okay? This here is called the diameter. It goes through the center of the circle and goes from one edge to the other. Okay? The diameter is always twice as long as the radius. Okay? So, for example, here, if I said, what is the radius of each figure? Well, in the red circle, we know that the radius is 8 centimeters. That's the radius. Here, in the green circle, what's the radius of each figure? Well, they don't give us the radius. They give us the diameter, because the diameter goes all the way across. So here, the radius would be 50 feet, because the radius is half of the diameter. So, number 27, in the diagram below, line segment AT is a diameter of the circle with center O. What is the area of the shaded part of the circle? Well, first of all, you need to know how to find the area of a circle. Okay, we have this nice circle right here. To find the area of a circle, you should know, well, on your reference sheet that they give you, they'll actually give you the formula for the area of a circle. Area of a circle is pi times the radius squared, right? That's the area of a circle. Area equals pi r squared. So they want us to find the area of the shaded part of the circle. Okay, the shaded part. So that looks like it's going to be most of the circle, right? It's going to be all of this stuff in here, all of this over here, all of this over here. That's the area that they want us to find. So let's type in pi r squared. Pi, most of the time you're going to use the number 3.14. They do have the calculator does have a pi button, but you should probably go ahead and just use 3.14 for pi. So pi times the radius, and what is the radius of this circle? Well, the radius is actually, from here to here, right? This is the radius from the center to the edge. So it's not that whole 16, it's just 8. Pi times the radius squared. Don't forget that squared, that's important. Okay, so let's go ahead and type that in our calculator. 3.14. So 3.14 times 8 squared. And we get 200.96. Okay, so the area of the whole thing is 200.96. Alright, that's the whole circle, including the shaded and the unshaded region. Now, we just want the shaded part of the circle. Now, we see that the shaded part is the majority of the circle. So we could probably eliminate a few of these, like this, because the shaded part is the majority of the circle, so it's got to be most of the circle. We can also eliminate that one because that's not most of the circle. And then you could probably even eliminate D because that's too much of the circle, okay? Because this triangle, it takes up not quite half, definitely not half, but it's going to take up a little less than that. So C is the only one that really makes any type of sense. All right, there's other ways to do this problem as well. You could have used a few things like knowing that since this is a 30, 60, because every triangle has a total of 180 degrees, this is a 30, 60, 90 triangle. That because this side here is 16, this side here had to be 8, and then you can use your Pythagorean theorem to find out what this side is. And then you could have done some, you could did your area for a triangle as 1/2 base times height, and so on and so forth. But honestly, this problem is a lot easier to do if you kind of just recognize common sense that this is the only answer that really makes sense. All right, Janice had a 5-inch high by 3-inch wide photo enlarged to a 3.5-foot tall poster. What should be the approximate width of the poster? Well, if we're going 5 inches high by 3 inches wide, we can set up a proportion. So 5 inches high to 3 inches wide is the same thing as 3 foot tall. So that's going to be the height, 3.5 foot tall, over what's the width going to be? Well, we don't know. We'll put that as x. From there, you can use this proportion and cross multiply. What's 5 times x? Well, that's 5x. What's 3 times 3.5? Well, let's see. 3 times 3.5 equals 10.5. So we get 5x equals 10.5. And then we can solve for x by dividing by 5 on both sides. So we get x equals, well, let's see, what's 10.5? 10.5 divided by 5 equals 2.1. So we get x equals 2.1. And there we are, 2.1 feet. All right. Some people say, well, shouldn't you have turned feet into inches here? When you're dealing with a proportion, you don't actually have to do that as long as the proportion you use is consistent on both sides. Here we had inches over inches. Here we had feet over feet. So it didn't really matter here. Okay? All right. Last one. Bart has a cylindrical pitcher with a radius of 6 centimeters and a height of 12 centimeters. He pours 1,300 cubic centimeters of lemonade into the pitcher. Approximately how much more lemonade will the pitcher hold? So listen, I would make sure that you read that problem over again. Make sure you get a good understanding. But Bart has this cylindrical pitcher. Okay. I'm not the best drawer, so you have to bear with me. All right. So there's our cylindrical pitcher. It has a radius of 6 centimeters. So a radius meaning going from the center. Let's do a different color here. Goes from the center to the edge of 6 centimeters. And a height of 12 centimeters. So that's from here to here. It's 12. He pours 1,300 cubic centimeters of lemonade into the pitcher. Approximately how much more lemonade will the pitcher hold? Well, on your reference sheet that they will give you before the test, they will tell you that the volume is how much something holds. Okay, volume of a cylinder is given by the formula pi times radius squared times the height. So all you need to do from here is type in the volume. Okay, we can find the volume of this pitcher by plugging it into this formula. So 3.14 times the radius squared, so radius is 6, so we're going to multiply it by 6 squared times the height, which is 12. Let's type that in our calculator, see how much we come out with. So 3.14 times 6 squared times the height, which was 12. And we get 1,356.48. So the volume is 1,356.48. That's how much the cylinder will hold. And they said that we already put 1,300 cubic centimeters in it. Let me put my units here, centimeters cubed. Okay, so since we already have 1,300 in there, we're just going to subtract the two. 1,356.48 minus the 1,300. So we would get about 56.48. Okay, and that would be approximately B. All right, hopefully this video has been helpful to you, and good luck studying for your OGT.